Welcome to a lesson comparing the solutions to homogeneous and non-homogeneous systems of equations. On the left, we have a homogeneous system of equations because all the equations are equal to 0. On the right, we have a non-homogeneous system of equations because all the equations are not equal to 0. However, for both systems, notice how the expressions on the left are exactly the same. To solve the two types of systems, we will set up an augmented matrix and then write the augmented matrix in reduced row echelon form. Because we have three equations with three unknowns, we have a 3x4 augmented matrix. Looking at the homogeneous system, the first equation gives us the first row of 1, negative 1, 2, 0. For the non-homogeneous system, notice the first row is 1, negative 1, 2, 5. So the only difference is in the fourth column, we have a 5 for the non-homogeneous system, and for the homogeneous system, we have 0. For the second equation of the homogeneous system, we have the second row of 1, negative 2, 1, 0. For the non-homogeneous system, we have 1, negative 2, 1, and then 2. For the homogeneous system, the third equation gives us the row 3, negative 4, 5, 0. For the non-homogeneous system, the third row is 3, negative 4, 5, 12. The next step is to write the augmented matrix in reduced row echelon form, which is here below. If we compare the first three columns for both the homogeneous and non-homogeneous system, notice how they are exactly the same, but the fourth columns are different. For the homogeneous system, the fourth column is all zeros. For the non-homogeneous system, the fourth column is 3. And now let's identify the basic variables and the free variables. We begin by determining the leading non-zero entries in each row, which give us the pivot positions. We'll notice in both cases the pivot positions are the same for both the homogeneous and non-homogeneous system. The pivot columns are column 1 and column 2, which indicate the basic variables, sometimes referred to as leading variables, are x sub 1 and x sub 2 in both cases. The variables that are not basic variables are free variables, which in both cases is x sub 3. X sub 3 is the free variable for both systems. The next step is to write the corresponding equations for each row in reduced row echelon form. For the homogeneous system, the first row gives us the equation x sub 1 plus 3x sub 3 equals 0. Notice for the non-homogeneous system, we have x sub 1 plus 3x sub 3 equals 8. For the homogeneous system, the second row indicates that x sub 2 plus x sub 3 equals 0. For the non-homogeneous system, the second row indicates that x sub 2 plus x sub 3 equals 3. And because x sub 3 in both cases is a free variable, meaning it can take on any value, we let x sub 3 equal x sub 3 in both cases. The next step for both systems is to write the basic variables in terms of the free variable, which means we need to write x sub 1, x sub 2, and x sub 3 all in terms of x sub 3. So for the first equation for the homogeneous system, solving for x sub 1, we have x sub 1 equals negative 3x sub 3. Notice for the non-homogeneous system, we have x sub 1 equals 8 minus 3x sub 3. For the homogeneous system, solving the second equation for x sub 2, we have x sub 2 equals negative x sub 3. For the non-homogeneous system, we have x sub 2 equals 3 minus x sub 3. And in both cases, x sub 3 is still equal to x sub 3. So this would be a common way to express the solutions to both a homogeneous system as well as a non-homogeneous system. Notice how in both cases, the variable terms are the same for both solutions, but the non-homogeneous system has constants in these solutions. Another common way is to parameterize the solution by letting the free variables equal a different variable. Because x sub 3 is the free variable, to parameterize the solution, we let x sub 3 equal t, which for the homogeneous system gives us x sub 1 equals negative 3t, x sub 2 equals t, and x sub 3 equals t. This would be another common way to express the solutions for a homogeneous system. Similarly, for the non-homogeneous system, if we let x sub 3 equal t, we have x sub 1 equals 8 minus 3t, x sub 2 equals 3 minus t, and x sub 3 equals t. Another common way to express the solutions to both types of systems is to write a matrix equation, which can also be referred to as a vector equation. So let's also show this. So beginning with the homogeneous system, we begin with a column matrix that contains the variables x sub 1, x sub 2, and x sub 3, which is equal to another column matrix, where in this case I'm going to include the constants of 0 just for a comparison to the non-homogeneous system. So we can write negative 3t as 0 minus 3t, we can write negative t as 0 minus t, and we can write t as 0 plus t. From here, we can break this up into the sum of two column matrices, where we have the constant column matrix plus the variable column matrix, which we see here on the right. And then to finish, we typically factor out the t from the second column matrix and write it in the form shown here below. In this form, we have the trivial solution plus t times the basic solution. Of course, we can leave off the trivial solution here, because when t is equal to 0, we do have the trivial solution. But one reason I wanted to show this form is it makes a nice comparison to the solution for the non-homogeneous system. So for the non-homogeneous system, we have the column matrix that contains the variables, and then on the right we have the column matrix of 8 minus 3t, 3 minus t, and we can write t as 0 plus t. And then from here we can break this up into the sum of two column matrices, where we have the constants in the first column matrix and the variable terms in the second column matrix. And again, the last step is to factor out the t from the second column matrix shown here below. So for the non-homogeneous system, this first constant matrix is called the particular solution, and the second column matrix being multiplied by t is called the basic solution. So notice how the basic solutions are the same for both the homogeneous system and the non-homogeneous system. I hope you found this helpful.